So actually, Power BI provides us by default a forecasting method. So if we have some time series data, we can actually use Power BI's inbuilt forecaster to make some future predictions on that data. And actually, this method that Microsoft uses, it's called something called Holt-Winters algorithm. So I will just try to basically cover like what all things this algorithm takes into consideration and how can we tune. We are actually provided with some hyperparameters here that we can tune and set. So how can we manage these things for getting optimal forecasts in Power BI? Yeah, but let's get started with the really basic stuff of forecasting. So uh, time series or series, this is one common terminology used in this environment. So basically any data which has sequential nature to it is called a time series data or simply a series. So for example, if you have a single column of data and it is said that it is a time series data, then that means that all the data which comes after a given row, it's like there is a sequence to it. We cannot apply things like sorting or filtering to this thing because the order will get changed. So like we have to maintain the order. But let's say if we have a single column of data which has some names, then that is not a time series data. So we can obviously do the sorting and all. So that's what's called a series or time series. Then we have observed and expected value. Whenever we are making any prediction, we have a so-called model with us, model or method. So a model outputs some value which it thinks emulates the real value. So the output that is produced by the model is called the expected value, and the actually let's not stick with this expected and observe. It's simply the output of the model or the ground truth that is the data that we already have. And the method is obviously the model or the thing that actually describes the relation of how that series is working. So actually if we try to see like what can be the simplest possible method to actually predict. Let's say we have a time series and let's say we are currently at the time instance t. So we want to predict what value we will have at time t plus 1. So the simplest method can be that, okay, we simply say that, okay, that value at time t plus 1 will simply be the value that we have at time t. This is the simplest possible thing, isn't it? We simply just carry on the current value to the future value. We say that, okay, that's our prediction. So actually there is no incorrect or correct prediction because prediction is anyway unknown thing. So there can be more logical predictions or naive predictions. So a relatively better thing could be to simply take the average of all the data points that we have thus far. So that way, what we can say that if we have, let's say, 10 data points and we want to predict the 11th data point, we can say that, okay, the 11th data point is going to be the simple average of the previous 10 data points. So that's also a really simple method. This can work only if our data is relatively constant with minor fluctuations. So, but a slightly better approach would be to take the average of not the entire data. If we have, let's say, 1,000 data points, so that will be really expensive to calculate the average of the entire 1,000 data points. So we can actually trim a so-called window, and let's say we take the average of the last 10 points or last 20 points based on how we feel about the data. So that's something called a moving average. And in addition to that, what we can do is that, let's say we are sticking with a window size of 4. So we say that, okay, if we are at time instant t and we want to predict the value for time t plus 1, we will take the average of time t minus 1, t minus 2, and t minus 3, the previous 4 time instances. We want to take the average of these 4. So one modification that we can do, if we find that the older values don't affect the future that much, then we can actually give something called weights, and we give less weight to the older value, the more older value, and we give more weight to the more recent values. So if we are at time t, so we can give, let's say, 40% weightage to time t and 30% weightage to time t minus 1, and 20% weightage to time t minus 2, and so on. Like progressively, we are reducing the weightage for the more older values. So that is what's called a moving average with weighted moving average. So just a recap of all these three methods. So let's say we have this random like time series data, and if we simply take the average of all the data points, this is the thing that we get. This is the prediction. If we take the average of last 4 without any weights, this is the prediction. If we take the weighted sum, this is the prediction. And average of only the window size of 3, moving average with window size of 3, this is the prediction. So obviously there is no correct or incorrect thing here, but like this is just a visual representation of what the performances will be for all these simple methods. So actually coming to this thing only, this weighted moving average, how do we actually, let's say we find that this makes sense for our case, that we have some weights. So how do we actually decide what weight to choose? One of the simplest method is that we say, okay, let's say we fix that, okay, we want to give the previous time instance a weightage of 60%. So how do I choose this value? I can say simply, if I find that this has to be lower than this, then I can say that like simply I will do 0.6 squared, and then for the one step even before that, 0.6 cubed, and 0.6 to the power 4, and so on and so forth. So we are essentially taking exponentially weighted sum. So this is what's called a single exponential smoothing. And this is actually the premise of the whole entire Hall to Winters thing. That's why I even came to this thing. So Hall to Winters does this thing only, like it takes moving average, weighted moving average, but the weights are assigned in this way. Like if one of the weights is 0.9, then the previous weight will be 0.9 squared, and then the one before that will be 0.9 cubed, and so on and so forth. So it will keep on progressively decreasing. If you think about it, like 0.9, 0.8, 1.729, and so on and so forth. So I think this is enough of like a basic overview for the method. Yeah, and so for this thing only, this exponential weightage thing, if we try to recreate the given data using this method, you can see like if there is a constant parameter, this weight thing only. If we choose the weight to be 0.9, then you can see like it follows the original data really closely. If we choose the weight parameter to be 0.1, it smooths out it smooths the data out quite strongly. So like this is much smoother. It does not have this sharp decline and rise, but it's smoother. So actually, what Power BI uses in its inbuilt forecaster is this thing only. But thus far, I showed you only a single exponential smoothing. It takes into the Power BI takes into consideration three things. What's called a level and a trend and the seasonality. So if we look at this data actually captures all three of those things. So level is just simply the average, the localized average of a data in a particular neighborhood. So let's say we are thinking about this range, September 1, 1952 to February 1, 1953. So whatever the overall average of this region is, that will be called the level of this region. Then there is something called trend. So we can obviously see that this data is clearly trending upwards in the long run. So this upward, or it may be downward as well. So this upward or downward thing is called the trend or the slope of the data. So Holt-Winters algorithm takes into consideration both the level and the trend. And finally, this we can see there are this seasonal type of peaks and valleys thing. So this has a repetition period to it, and it keeps on repeating. So this is what's called the seasonality. So one of the examples to understand this is actually this data is from the air traffic control data. So this actually represents that near the summer time, when people get their holidays, summer holidays, the flight tickets actually, the demand of flight tickets skyrockets. And as we approach the November or September months, then the demand stays relatively lower. So that's one seasonal pattern. That's one example for the seasonality thing. So the Power BI takes into consideration all these three things. What's the general level there? What's the trend? Is it trending upwards or downwards? And what's the seasonality? Yep. So for actually doing the predictions in Power BI, we simply have to do this thing. We load our data. We plot a line plot. This works with line plot only. So we just come to in the visualizations panel, this further analysis. Here we have the forecasting. We just turn this thing on, and here we will be provided with lots of options. So this point thing doesn't matter much. What this is that it just we basically want to define what is the granularity of our data. So if we look closely at our data, this is monthly data. So like the minimum time step here is the months unit. So like December, then January, February. It's not day wise data, it's monthly data. So we can choose what type of data it is here. And forecast length, like how many units do we want to predict. So let's say we want to predict for 3 years. So 3 years, that would be 36 months. So if I just choose months and do this 36 here and say apply, so it will make predictions for 3 years. So obviously our data has a yearly seasonality to it, that it repeats every year. That's why we have three sort of peaks here. And obviously the blue line represents the true data that we have, the historical data, and the gray one is actually the predicted data that Power BI is providing us. Yeah, so after that there is this thing called seasonality, which is currently auto. So this seasonality actually we have to set ourselves mostly, because this data is extremely seasonal, isn't it? Like we can clearly see the repeating patterns, but it may happen that the data that we are working with is not as it's not as clearly visible as to what its seasonality is. So seasonality is simply that thing only, like after how many points the data repeats. So we can see that let's say this is one of the values, it's at November 1. For the other season, again we see the value occurs at November 1. So November 1 to November 1, this means the seasonality is completely 1 year. So we can set the seasonality to 12 points, because we know the seasonality is 1 year, that is 12 months. And then if we apply, it remains the same, because Power BI for this simple data was able to automatically deduct this value of 12. Yeah, but if the data is more complex, where the seasonality is not as quite obvious, then we would like to choose this value on our own. Then there's this confidence interval. This just says like Power BI doesn't, along with the actual prediction, it also provides some expected maximum and expected minimum value. And this confidence interval is regarding that thing only, like uh, how much confidence does it have that the value, the future value will lie within this range. So it has basically 95% confidence that for yeah, for example, that on July 1, 1962, the value, the actual value will, although its forecast is 726, it says that it's 95% confident that the value will lie between 856 and 597. So that's the thing. Yep, and there is one ignore last also. This is just for validation purpose. So let's say if we want to see, if we want to hide, let's say 1 year worth of data, and we want to see how does the prediction of Power BI compares to the actual data, then we can set the ignore the last two. Let's say I want to view the performance for 1 year, then I would give it 12 months. If I apply that, so you can see what happens now is that we have both predictions and the real value for this particular 1 year of data. So using this, we can actually validate that, okay, the predictions provided by Power BI matches the actual data rather closely. So we can say that, okay, this prediction is working fine. This may not always be the case though. For example, for stock prices, this is not the case. Like stock prices don't really have a regular seasonality to it. So it is not even recommended to use this Power BI's forecaster with complex data like stock prices. But yeah, for these type of data like trends and uh, uh, one use case for Eton, one of our clients was that they have some weekly data, and they said that what happens near the weekend is that uh, the data that they have is actually uh, quite unclean, and it has lots of missing values. So they want to use the Power BI's forecaster to predict those missing values. So that can be one of the use cases when we do have a defined seasonality, and let's say we want to predict the some missing values or maybe corrected values, then we can use this tool. So I guess that's it. If you have any doubts, you can ask me.
Yeah, Dishan, one question. Right, when you explained about the whole twin test method at the starting, right? You mentioned that it is exponential smoothing technique, right? And you also said that it takes into consideration level, seasonality, and the trend, right? I can
Yes,
understand.
yes.
I can understand that exponential smoothing takes care of trend and level, but I'm not really sure how seasonality can be taken care of using just by
Yeah,
exponential
so
smoothing.
yeah, let me share that. Actually, it gets quite complex. That's why I didn't show it. So
Okay.
essentially, what happens is that the general format of a exponential smoothing equation is that the value that we are predicting is some constant times the real value plus one minus that constant times the previous prediction.
Mm.
That's the general
Yeah.
framework of the exponential smoothing equation. So
Yeah.
they actually apply the same equation for all three things: level, trend, and the seasonality. Even for seasonality, they have applied this equation.
Mm.
So
Okay.
that's why it's called triple smoothing equation. Holt Winters is called.
Okay. Cool. Thanks.
And in the actual forecast, final forecast, all they do is that they simply the level that they obtained from the exponential smoothing, they put that, they add the trend to it, and they also add the seasonality to it.
Mm.
That's it. They just simply add it, add
Okay.
all the three components.
Got it. Okay. Cool.
Zishan, the conference interval, right? How is it defined there? Like, what percentile is the conference interval?
Yeah, so actually, a rough overview of that thing is that the higher the confidence, the wider the expected maximum bound will be,
Uh,
and the lower the confidence, the narrower the bound gets. And
so, okay, can you just share that
yep.
thing once? So not the formula, like yeah, this one. So what is the percentile interval that it shows for the
It's
upper bound to the
95.
lower bound?
It's 95% here, so I think it's plus or minus
Oh,
1.
okay, got it.
The value we have to choose. So for instance, currently it was at 95. If I choose the 99, then the range gets slightly wider. Uh,
Okay, got it.
like yeah, so like value is upon us to choose. We can choose the confidence interval.
And does the research that you've done show how this conference interval is like computed?
Yes, yes.
Can you
So
talk a little bit
actually,
about that?
yeah, there are two cases because Microsoft don't actually provide their algorithms. So I observed two cases when there is this neat sort of seasonality, and the Power BI is actually able to make good predictions. For example, here we can see it's making relatively well guessed predictions. Here, the confidence interval is actually dependent on two things: the general mean of the data where we are making the prediction, and the value. And obviously, they are simply linearly related. The higher the confidence interval percentage, the narrower the band gets. And it's like a linear relation with the mean. But if you have some erratic data like stock prices, then you will see that a really bad confidence. You can is my screen visible? This is
Yeah.
supposed to be Apple stock price. Yeah, so you can see that it is making their periodic predictions, But you can see that the confidence interval, it's simply, I observed it simply a y equals x square graph. So they don't have much confidence actually for erratic data. So two separate behaviors are there. So if Power BI is unable to actually find the correct estimate for the data, then it simply provides a ever growing quadratic sort of confidence interval. But if it is able to match the data, then this confidence interval is simply linear function of the general mean that is here and the percentile value confidence interval that we choose.
Okay, so like there's no clear like
Yep.
documentation on that, like how they calculate that.
In their documentation, they did not provide any information about this.
Okay, okay, because at some places even that prediction, like they have a very small confidence interval, and some places they have a larger confidence interval. Okay, okay, yeah, thanks.
Zishan, I wanted to ask, like, does the Power BI allow us to use some other methods or other algorithms instead of this for prediction? Like for stocks, we may try to use LSTM or stuff. Does the Power BI allow that to, happen?
Yeah, so that will actually depend. Like if we have custom model, I don't think custom models will mostly be run by Python. So we might have to look into the interface between Python and Power BI. But as it is, I don't see it providing the other. There is no provision for our own algorithm in this forecaster.